Assalamualaikum, and today we will be talking about the execution flow of a Java program, and we'll also be diving into what's JDK, what's JRE, and what's JVM. So without further ado, let's get started. Okay, so whenever you write a Java program, it basically, or whenever you write any program, it needs to be translated into machine code, right? That's what compilation is. So here in Java, it's basically done in two steps. The first step is called compilation, and the other is basically called execution. So what happens is your Java code, which you write in a file with an extension of .java. So this is the file in which you write your code, uh, or in other words, it's simply the source code, right? Now, using a compiler which is called Java C, this code here that you wrote in this file gets translated or compiled down to a bytecode. Mind you, that's a bytecode and not a machine code, right? So it basically is translated into a bytecode, and then it's stored in a file which has an extension of .class using a compiler Java C. So this compiler takes this code and translate it into the bytecode. Now, why is it called a bytecode? It's called a bytecode because it has an instruction set of 8-bit of size. That's why it's called a bytecode. Now, this bytecode is platform independent because it's not machine code, right? So it's not machine specific. You can run this bytecode on any sort of machine on any operating system. So this whole first step gives you the bytecode of your code, which is in a file with a .class extension, and that gets stored. That's platform independent, or operating system independent. So you can run it anywhere on any machine. Okay, so now let's move to the second part of the execution. Second part, which is execution. This takes as input the bytecode, which is the result of the first step here. So now the bytecode is taken, and it basically gets passed to a virtual machine. Now, what's virtual machine? What's a JVM? We'll talk about that in a while. But just assume and just create an illusion that this .class file is basically passed into an environment, into a virtual machine here, which itself has three parts. The first part that it has is a class loader. The second component or part it's a bytecode verifier, and lastly it has an interpreter or a JIT compiler. So what happens is, whatever this byte code is, it basically gets loaded to the JVM memory using a class loader. This class loader is responsible for loading whatever the bytecode here is into the JVM memory. In the JVM memory, it basically takes and verifies that code if everything is fine or not, if there's a bug or not, those kind of things. Once it's done, then you have an interpreter that basically interprets your bytecode and converts that into machine code. Now, what's an interpreter? Interpreter basically takes your code, reads it line by line, and then converts it into the machine code. So whatever code you have there in this .class file, that will be read line by line and will be translated down to the machine code. That's what interpreter is. That's what interpreter do. And because it converts line by line your code to a machine code, it is comparatively slow as compared to your compiler. So you have other thing which is called JIT, which is just-in-time compiler. It basically itself has two sorts of compilers. One of them is C1 compiler. The other one of them is C2 compiler. Now what happens is, sometimes you have instructions in your code which are repeated. For example, there's a print function which is getting repeated, the exact same function. What this JIT compiler will do is, it will take those repeated instructions, and the C1 compiler, this will basically compile it and will store it in the cache, so that the next time your program is loaded, instead of compiling it from scratch again, it reads that part from the cache. But what happens is, sometimes those repeated instructions are there in the code, but but that particular flow is not is not very frequent, right? So what C2 compiler does is it basically fetches and checks, it basically does profiling and checks what are the flows which are, you know, which are like the hot flows, or the flows that are frequently called in your code. Those flows and the code respective to that, to those flows, is basically compiled down using this C2 compiler. And then again, it's it makes it easier, it makes your compilation process more optimized, because if you have an interpreter which is converting all of your code one by one, line by line, it will take more time. But if you have that frequent chunks of code and frequent piece of instructions being stored and being compiled via compiler, it will be faster, because compiler basically takes the whole instructions. Like if you have 5 lines of instructions, it will take the whole 5 lines lot and will convert it down to machine code. On the other hand, interpreter would take line by line and will convert each instruction, each line of code to machine code one at a time. So that's why JIT is used, and it basically way of optimizing your or making your compilation process faster. So that's how this interpreter or JIT basically converts your code, your bytecode, into machine code. Now all these 3 components are basically a part of a Java runtime environment. We'll see what's JDK, JRE and JVM in a short while, so that it will give you a more clear picture. Okay, so let's see what JDK is. JDK is basically Java Development Kit, and it's nothing but it just provides you an environment with which you can develop and run Java programs. So we as developers need JDK so that we have an environment where we have the available tools and the available environment where we could write Java code, where we could develop it, where we could execute it, right? So you need a runtime environment as well as the development tools. So JDK is basically consists of 2 things. It consists of JRE as well as the dev tools like compilers, interpreter, etc., which is needed to run your code. Now let's talk about the JRE. JRE is itself an environment that is only needed to run, that is to execute already developed program. So you don't need to develop or write code. You have the code, you just need to run that, or you just need to execute that. So that environment is basically JRE, and it's usually required by clients so that you can provide your code to them and they can just run it. They don't need to code it, they don't need to develop it. They have the developed program and they just need to execute that or run it. Okay, moving forward, then you have JVM. So JRE basically consists of, so if I talk about JRE, it basically consists of JVM itself, which is a specification plus some other library files, right? So what JVM is nothing but Java virtual machine. So Java virtual machine, it's basically a specification. It provides a standard, it specifies certain things. It doesn't physically exist, right? So it's an abstract machine which basically gives an illusion that your code is running in a virtual machine. So on first layer you have JDK, then inside that you have JRE, and inside JRE you have JVM. Now if I go back to the diagram that I was showing you earlier, this whole thing is basically under the part of Java runtime environment, and the Java runtime environment itself has the JVM interpreter and things like that. So these things are present inside. This is basically the JVM part of JRE. So this was it, guys, for the execution flow of a Java program. I hope you like this video. If you do, please like, share, subscribe, and for any kind of feedback, the comment section is always open, and I'll see you in the next one. Bye bye. Allah Hafiz.